Hello everyone, Cliff here in the shed again. Want to do a job on my milling machine. Right, so here's my milling machine, and one of the first things I did when I got this was made this little extension, and I had a little electric motor which is connected up to a box up here. It's just a little 12-volt motor. And I had this screwed onto here. This is the original plate off of here. This was screwed onto here, had these extension bits on it, and I had this plate over here with a motor mounted on it. And then I had this bit that I could slide backwards and forwards to engage it on there. Basically that gave me a power feed for it, but the little motor weren't really up to it, and I mean the motor was up to it. It was a little Banggood thing, little 12-volt motor with a gearbox, but anyway that went by the wayside, and I've been meaning to sort something out with it for a while. So I've got another golf trolley motor here. These are brilliant motors, these golf trolley motors. They're a 12-volt motor, they're really high torque, they've got the gearbox. And basically I need to fit that on there with something to engage this, with a motor on there, and then back up to me control unit which is up there. So like I say, this is the original end off of here, so I've got to make something like that with a bit of an extension on it, so I can bolt it back onto here and bolt it onto here. And I was thinking about making it out of aluminium or a couple of bits of aluminium, and then I thought, I wonder if I can print it. So off to Fusion 360. So here's the design in Fusion 360. I'm sure there's better ways of doing this. It's basically just an L-shaped bit of metal, or a bit of plastic in this case, with some holes cut out of it. So do that in Fusion 360. I'm sure you're getting all this reflections and that on there, but hopefully it'll come out alright. And then put that in the curer, not that one. And then that goes into curer, which then goes onto an SD card and then off to the printer. So this is the 3D printed bracket thing. I did, as an afterthought, put some recesses in the back cells, because I think that this one in particular is going to be below the surface of the mill table, so I'll have to put a nut in there when I bolt this onto it, and then bolt the motor onto it. Right, but now I've got to make a don't know where it's gone. Oh, there it is. Right, I've got to make another version of this. This is what pops onto there that's got to be locked into the motor to drive the table. So I've got to make one of them. Now the diameter of that hole there, where that's going to go over that driving bar, is the dead on 12mm. I've put a bit of 12mm tool steel through there, which is ground, which is pretty perfect, and that's got a lovely sliding fit through it. So I don't want to waste a bit of that on it because it's too dear. I've got this whole piece of shit metal here that I've just cut a bit off. It's about 15mm diameter. And I've got that in the lathe. It's very hard, I don't know what it was, but it's very hard material. So I've got it down to about 13.5mm now, and I've got to get it down to a nice sliding 12mm fit. What I thought I might do, I mean, I've got to get it down so that it will slide in and out of the motor, and then I've got to get it on the mill and mill out the slot so it will go over the the driving bar on the, it's not a driving bar, it's the oh, I don't know. Anyway, so I've got to get this down to 12mm. Right, that is 13.6 at the moment, which I've now got to convert on my Imperial lathe. I'll set that to 0. Oh, bollocks. I'm going to have to move the cutter out of it because this tool post is in the revolving centre. You bastard, move. That should be enough. Now I'll set it to 0 and take a millimetre off it. Alright, it's as rough as a badger's arse. I actually took 20 thou off it. Well, a 20 thou cut, which is 40 thou off the diameter, which is about 1mm, which is pretty good. It's about 12.6. So I'll take 0.5mm off it now. Should have left that where it was. I'll slow that down a bit. Revs are about 440 at the moment. I've got no idea what the speed of the feed is that fast. Still as rough as a badger's arse, and it's hot. It's just over 12.1 at the moment. I'm going to let that cool down and measure it again and then try it. Let's try it on that now. So. That won't go on there. Nearly though. I'm going to let that cool down. Because it is red hot. And I'll come back. Alright, it's cooled down now. I'll give it another measure. It was just slightly over 12.6 before. It's even more over 12.6 now. Strange. Alright, that's a bit too much to it's not 12.6, I've misread it, it's just over 12.1, dickhead. I was just about to take 0.5mm off of that. Alright, I think I'm going to get a bit of paper. Alright, I'm going to put the lathe in reverse and I'm going to use one of me, I'll use a fine one. I've just got like a little Dremel tool here with a hand mount. I'm just going to see if I can grind that off. Give it a measure, but yeah, it's took hardly anything of it. It's made it a bit smoother. But that is almost there. I'll use a rougher one. Very close. That's lovely. That's going on there a beaut now. Right, because my intention is just to Loctite this in after I've got the slot cut in it. And that's a lovely fit on there now. Right, to the mill. So I've just got it upright in the vise there, and I've centered it with an upside down drill bit into the hole that the centering bit made on the lathe, so I can lock the y-axis off and then get on with putting a 5mm slot in it. Oh, I'm just going to touch this off and then do the slot. I need to know how deep to go with the slot, don't I? Yeah, it wants to be about 6mm, so I'm going to touch it off and then get on with it. Z. That's him, fit on there. Right, I've got to clean this up. Right, I can't find no I ain't got no bolts long enough for it, so I've got to improvise a bit. This one's got a captive nut in it. Right, so now I need to know yes, that's it, that's engaged with that. So now I've just got to screw the motor on it, wire it up and see how it goes. Well, it's been over a week now since I last turned the camera off. Part of that is because I went to Scotland for a week. 4 days, 5 days. Stayed in a lovely place called the Allen Park in Stirling. Had a lovely time, brilliant staff. Well worth your money if you ever go visiting Stirling. So, last time I was here, I've just got this mounted up. I've put the motor on. Now, I did try it out briefly on the control box, and this is the control box that I had in the box at the time. This is a 20 amp controller. It worked alright, but it wouldn't do it slow enough. It would go fastish, but wouldn't go slow. This is the switch I had in there. I just had to cross it over because I had the motor coming directly off of this so that I could forward and reverse it. So anyway, I bought another 60 amp gubbins, which is now up in the control box here. Right, I'll move the camera a bit so you can get a better look at it. I'll move that out of the way. So this is the control box. It's got forward and reverse switch here and an on off switch here and the speed control. I don't know whether the camera's going to pick this up. You've got a little, with this motor came this little readout, and it goes from nothing to 100 and the switch off. I've just got this wired up to a 12 volt battery at the moment, but if I switch it so it's coming this way, hopefully the camera will pick it all up. Switch him on, we've got a 0 there. And there he goes. That's full speed, that's 100%. slow it right down. I don't know if it's going to pick that up moving. I'm not sure if you can see the handle on the other end. Yeah, just about see the handle moving now. Send him back the other way. Slow it right down. About 15 is about as slow as it'll go. Beyond that, I just don't think there's enough current in it to. No, enough. I mean, it's still going. Yeah, about 11, 10. If I go down to 10, it stops. It's actually still going ever so slowly, but that's about the slowest usable speed you'd get. But that's it. It's all working at last. I don't think there's anything else to it. I just Loctited the bar I made into the bearing. Can always warm this up and take it out if I need to. You have to excuse me, I've got a bit of a dodgy throat. All that good clean Scottish air, my lungs ain't used to it living down here in the southeast, in the shitty southeast. Now I know some of the purist sheddies out there are going to say making something on your 3D printer for your shed is a bit of a cheat. But basically I wanted to get this motor on here and this was the easiest way to do it. So it got the job done and I'm quite happy with it. I mean, the whole point of doing this, it's not just purely laziness, although that does come into it a bit, because you've got to go banging up and down 10 or 12 inches on this by hand. It does make your hand ache a bit, but it's the steadiness of it really. You can get that going at a nice steady speed, and any of you who've done any machining, you'll know that whether you're on a lathe or a milling machine or whatever you're doing, the steadier you can get the feed rate, the better finish you get. Anyway, that's it for this one. Thanks again for watching everyone, and I'll see you again on the next one. Bye for now.